Hello everyone, I am Pranati Reddy from Sri Venkateswara College of Engineering from the Department of Basic Science, Computer Science and Engineering. Today I am going to talk about data types in Python, functions in Python, exception handling, program. Introduction to data types in Python. Python has several built-in data types including int, float and string. Data types determine the kind of operations that can be performed on data. Understanding data types is crucial for effective programming in Python. Numeric data types. Numeric data types in Python include int for integers and float for floating point numbers. These data types can be used in mathematical calculations and operations. Python provides various functions for working with numeric data types. String data type. Strings in Python are sequences of characters enclosed in single or double quotes. String data type supports various operations such as concatenation and slicing. Python's string methods allow for manipulation and formatting of string data. List data type. Lists in Python are ordered collections of items that can be of different data types. Lists are mutable, meaning of elements can be added, removed, or modified. Lists comprehension provides a concise way to create lists in Python. The list data type is a fundamental data structure in programming that allows you to store a collection of elements such as numbers, strings, or even other lists in a specific order. Dynamic size. Lists typically have dynamic sizing, meaning they can grow or shrink as elements are added or removed. This flexibility makes them useful for situations where the number of elements is not known in advance. Heterogeneous elements. Lists can hold elements of different data types. For example, a list can contain integers, strings, floats, or even other lists as its elements. Functions in Python. Functions are reusable blocks of code that perform a specific task. Functions help in organizing code, improving readability, and reducing redundancy. In Python, functions are defined using the del keyword, followed by a function name and parameters. In function, you define a function and then call a function. In calling a function, after defining a function, you can call it from anywhere in your code. Return statement. Functions can optionally return a value using the return statement. If no return statement is used, the function returns none by default. Scope. Variables defined inside a function have a local scope and are only accessible within that function. Variables defined outside of any function have a global scope and can be accessed from any part of the code. Parameters and return values in functions. Parameters are inputs to functions that allow passing data to the function. Return values are outputs from functions that provide results back to the caller. Python functions can have default parameters and return multiple values using tuples. Exception handling. Exception handling in Python allows for graceful handling of errors and exceptions. The try except block is used to catch and handle exceptions in Python code. Exception handling prevents program crashes and provides error messages for debugging. Exception handling is a crucial part of writing robust and reliable code. It's about anticipating and handling errors or exceptional situations that may occur during program execution. In most programming languages, including Java, Python, and C, you typically use try catch blocks to manage exceptions. Try block. This is where you place the code that might throw an exception. If an exception occurs within the try block, it's caught by corresponding catch block. Catch: if an exception type, or subclass is thrown within the try block, it's caught here. You can have multiple catch blocks to handle different types of exceptions. Finally block. This finally block is exceptional and is used to execute code that needs to be run whether an exception occurs or not, such as closing resources like files or database connections. Throwing exceptions: you can also manually throw exceptions using the throw keyword. This is useful for signaling errors or exceptional conditions in your code. Proper exception handling improves the robustness of your code by gracefully dealing with unexpected situations and providing meaningful feedback to users or developers about what went wrong. Handling specific exceptions. Python provides specific exception classes for different types of errors. Developers can define custom exception classes to handle specific scenarios. Using multiple exception blocks allows for handling different exceptions separately. Guess the number program. Import random. Num is equal to random, randint, 1 to 10. Guess is equal to none. While guess is equal to num, guess is equal to input, guess a number between 1 and 10. Guess is equal to int guess. If guess is equal to num, then print congratulations, you won, and break the statement. Else, print nope, sorry, try again. Thank you.